So, hello everyone, it's a pleasure to be here. My name is Peretz, I'm the Director of Engineering in Carrar. So Carrar, it's a company that specialized in design, manufacturing, and delivery of superior battery modules for the automotive industry. We leverage a unique thermal management system based on two-phase immersion technology to provide a holistic solution for the entire vehicle. Now, our products line focuses on battery modules with integrated two-phase immersion thermal management, but also power electronics and in-vehicle computing based on cold plate evaporators. Now, over the past 3 years, we did a lot of projects, very successful projects with OEMs and Tier 1 companies in the fields of battery performance, lifetime, and safety. And also, we have our very powerful strategic partners, that some of them are also our investors, that help us to speed up the penetration to the market and maintain the quality of our product during mass production. Now, despite the high efficiency of electric vehicles today, there are still major challenges to deal with, such as long charging times, sensitivity to extreme weather, short battery life, range degradation, and even battery fires. Now, Carrar solves all of these problems. With our system, the battery conditions remains at the optimal range at any weather, at any driving conditions. Also with the ability to dissipate very large amount of heat. And with our temperature control, we can guarantee steady and uniform temperatures inside the module, which this is alone highly contributes to the battery lifetime, performance, and safety. Now, all of these advantages comes with very low form factor and very low parasitic energy, which means very efficient and compact system. Now, let me give you this. With our system, the vehicle can reach over 1 million kilometers. Now, I know it sounds imaginary, but let me explain how. Here in this graph, you can see lifetime test results for two identical modules with the same cells inside and the same charging and discharging protocol, with the only difference of our system. Now, you can see that our module reached almost 2,400 cycles, that equivalent to 1 million kilometers. But not only that, it also maintain the available energy, the capacity of the battery, constant during the module lifetime, which basically means that from charging to charging, the range remains the same. And you cannot say that on the other module, which you can see this sharp degradation of the capacity. Now, we believe that based on that and based on a lot of other tests that we did, that our system can create three major impacts. The first one is to eliminate the range anxiety around electric vehicles. The second one is to provide a proper second life for the batteries that leave the vehicle. And of course, open up the option for second-hand market for electric vehicles. And these points can push very fast and very strong the adoption of electric vehicles in the market. Now, at the beginning of the year, we completed our round A, which raised a little bit more than $5 million. We invested our efforts and resources in developing and testing our product. We did projects with OEMs, and we started, and actually right now at the final stages of the company qualification according to the IATF standards to become a qualified vendor for the automotive industry. Right now we're heading towards another funding round, which we're planning and want to raise at least $15 million with the main goal of building a production line for small volumes. Also, we're planning to start a development process with an OEM to reach start of production for the platforms of 2028. Now, before I finish, I want to leave you all with the taste of what we believe is our biggest value to the market. As I mentioned before, Carrar solves a lot of major problems. It enabling ultra-fast charging, extending the battery lifetime, and preventing fires in the batteries. But what behind all of this is the actual ability to change the way people see and think about the disadvantages of electric vehicles today. And it can really change the demand for electric vehicles in the market. Now, this is true value. I invite you all to dig more, and thank you very much for listening.
Thank you so much.
Thank you very much, Shai from Orbia. Wasn't clear if this need to be added before you produce the battery or the car, or it can be added also after.
It's an integral system as part of the vehicle. What we actually provide is a module with integrated thermal management. We remove the existing thermal management system that's based on a cold pipeline array that with the glycol flow, and we remove it and we replace it with modules that support this thermal management system with all the advantages of it.
Okay. Maria from Tehran. Did you engage with the producers of batteries today? What feedback do you get from them? Is it easy to implement, or it requires huge change in the production lines?
So, of course, there is challenges, but actually we did a lot of projects with OEM companies and also battery manufacturers. The results are amazing. The ability to ultra fast charge and the battery lifetime especially, and also safety. We also do safety tests in our facilities. The results are amazing, and the production line conversion to our technology, we actually need to build a production line for our modules, but there is also the side of the system, thermodynamic system, which includes mutual development with the OEM.
Thank you.
Can you specify the number of how many watts can you remove per centimeter or whatever?
Sorry?
And also, how do you cool your liquid eventually? Or how do you cool it? I mean, it's a closed
yeah,
loop.
it's a closed loop. It's a two-phase immersion loop, which means the batteries are fully immersed inside the module. It's like liquid that covers the entire batteries.
So where is the evaporation?
Yeah, it boils due to the heat from the batteries, and vapor leaves the module to the rest of the system, to the compressor and condenser, and then comes back through expansion valve or the rest of the thermodynamic loop.